Hello and welcome! So yesterday I received an interesting question from one of my students on binomial theorem. And you should know that the word interesting and binomial don't usually come in the same sentence. That is because usually in binomial theorem questions, you get really boring questions that are very grindy. What is grindy? You just need to follow a certain steps. Make sure your working is meticulous, be very patient, work it out, you will get the answer. This question is none of that. Okay, this question is challenging, okay, and it forces you to use some problem-solving skills to apply your knowledge on binomial theorem on a real problem. Okay, and that's why I think this is a really good question that I should share with everyone. Okay, so let's look at the question. It says, using your knowledge of 1 plus x to the power of n, using the expansion of that, can you please tell me why 37 to the power of 11, which is a really large number, and then you minus 1, is divisible by 396, right? So you'd be like, what is going on? Okay, but before we dive into the problem, let me just tell you another interesting thing about this question. Okay, it is not divisible. Okay, so let me prove to you it is not divisible, right? And I'm going to use Python or any programming language that you like, actually. Okay, so what we have here is 37 to the power of 11. Okay, to the power of is 2 multiplication signs, 37 to the power of 11, and then minus 1. Okay, and Python has this very interesting operator. So operators are things like plus, minus, times, and divide. Okay, so this operator is called modulo. M-O-D-U-L-O, modulo is represented by the percent sign. Okay, and this modulo operator is very interesting, or helps us a lot in this question. So if I do 20 modulo 5, you might want to think of this as 20 divided by 5, but it gives you the remainder instead of the answer that we want, which is 4. Okay, so if I run this, control enter, you should see a 0 because it gives no remainder. Okay, say if I do 21 modulo 5, now I expect the remainder to be 1. There you go. So that's modulo for you. It just gives you the remainder, which is very convenient if you want to check if something is divisible, right? So 37 to the power 11 minus 1 modulo 396 should be 0, right? So that's what we're going to check with Python. Okay, so 37 to the power 11 minus 1 is my number A, so I don't have to type it out again. Okay, and then if I divide by 396 or modulo 396, I should expect a 0, but it is not. It is not divisible by 396. Okay, however, I still maintain the opinion that this is a very good question. Why is that so? Because it forces you to dig deep, right? Go deeper and deeper into the magical wonderland of mathematics and discover some very interesting things that you would never think of unless you're willing to get your hands dirty. So let's do it together. Okay, so in order to make this question work, let's make a small modification. I'm going to actually make the number not 37 to the power 11 minus 1. I'm going to minus another 36 to the power 11. Okay, some of you might ask, hey, wait, if the remainder is 36, just minus 36 lah. Yes, that can work, but I chose 36 to the power 11 for a very specific reason, and you'll see why later on. Okay, and let's just make sure this works. Let's run. Okay, our new remainder after subtracting 36 to the power 11 is now 0. This is a working question now. Let's go back and let's change our... Now this question will work, and another thing that you want to know is that 396 is 11 times 36. Okay, so let's get started. Let's get started with this ridiculously huge number, 37 to the power 11. Okay, and this should sort of trigger the binomial in your head, like, oh wait, isn't binomial, supposed to help us to, work out the expansion of 2 terms inside a bracket raised to a high power like 11? Aha, yes. So shouldn't I try and split 37 up into something plus something? Okay, and my choice will be 1 plus 36. 1 plus 36. And you might be thinking, oh, why don't we try 2 plus 35, 3 plus 34, or other options that you might have. Okay, so let's list out the first 3 terms. 1 to the power of 11. Had you chose 2 plus 35, you will need to do 2 to the power of 11. which is not nice, right? Compared to 1 to the power 11, 1 to the power 10, 1 to the power 9, 1 to the power 8, so on and so forth, it will always give you 1. So here's interesting fact number 1. We mathematicians love the form of 1 plus something raised to the power n when we do binomial, for that very reason. Okay, so I believe most of you are going to go to JC to do H2 mathematics, and you will see that, yeah, this is actually one of the things to look out for, making sure that one of your terms is actually 1. Okay. So let's do a bit of simplification. The 0th term, this one, is going to be 1, because 11 choose 0. You need to remember your Pascal triangle, right? Pascal triangle, say we look at row 11. The first member and the last member will always be 1. And the second member and the second last member will always be the row number itself, 11. So what that means is that the Pascal triangle for row 11 looks like 1, 11, something, 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 11, 1. Okay? This is always true no matter which row you are in. Okay, and remember on the left hand side, this is actually equivalent to 37 to the power of 11. Now let's minus 1 on both sides. If I minus 1, then this will disappear from the right hand side. Okay, so the question that comes to your head is, can I divide, equally by 396? Can I divide this by 11 times 36? Then can I divide this by 11 times 36? Okay, looking at the first term over here, you have no problem. We have no problem dividing by 11 times 36. Yeah, we have 11 here, 36. That's nice. For the second term, there's a bit of, okay, I can divide by 36, but does 11 choose 2? Can I divide this by 11? Right? Same for the next term, 36 cubed. Yes, I can divide away 36, but can I divide 11 from here? Okay, so here's interesting fact number 2. Right? If you actually work out the Pascal triangle for row 11, okay, you might realize a pattern, and that is all the members of row 11, barring the first and the last member, which are 1, everything that I've highlighted in the middle are multiples of 11. They are all multiples of 11. And this phenomenon, right, where every member except the first and the last are multiples of the row number itself, only happens for prime numbers. Row 11, row 7, row 5, row 3, row 2, right? This will always be true. If you work out row 13, this will be true as well. Okay, if you want to know why this always works, you can attempt the proof yourself. It is not out of reach for a secondary 3 or secondary 4 student. You just need to think about how to express all these members of the row in terms of their factorial. And then you can see very clearly why prime numbers always exhibit this behavior. I'll leave you to try that out on your own. But for now, we have come to a very interesting conclusion, and that is this is a multiple of 11. I can say this is k times 11. I can say this is m times 11. And the next one will be probably p times 11, so on and so forth, until the very last term. Why? Because the very last term is 11 choose 11 times 36 to the power 11. Why is that not a multiple of 11 times 36? Because the last member, remember, of the row is 1. You can't get an 11 from there. So this guy needs to be subtracted. Okay, so now you remember why my suggestion, okay, let's remove this thing here. I don't want to divide by 396 yet. This is why I suggested the question to be 37 to the power 11 minus 1 and minus 36 to the power 11. If you do this, the question will be alright again. You actually get 11 times 36 plus 11 choose 2 times 36 square plus dot 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 up to 11 choose 10, 36 to the power of 10. Okay, and all these terms on the right hand side are completely divisible by 396. So what do you think? Was this an interesting question? To me, I think it was really good because we learned quite a number of things that are very, very beautiful about mathematics, or what I think is beautiful. It may not be beautiful to you, right? Just let me know what you think, and I'll see you hopefully in another interesting video. So catch you on the flip flop.